In this video, we're going to add vectors using the parallelogram rule. Step 1, both vectors have to have the same initial point. So I need to locate the vectors so that they share the same initial point. Step 2 will then create a parallelogram. And then step 3, the sum is going to be the vector that has the same initial point as the two vectors and is the diagonal of the parallelogram. So here we have vector A, and I used the same exact vectors as I did in the last video. So if you look at the last video, you'll see that we have this video right here where we've got vector A, vector B, and then the sum A plus B. I copied the same exact vectors, I just broke them apart, and I'm going to put them back together again. Now what we did in the last video was we lined them up initial to terminal, and then we got the sum initial to terminal. I'm going to this time use the parallelogram rule. So I'm going to have the two vectors share the same initial point. So right there, we share the same initial point. I'm very sorry about that. That's very funny. So here we have the vectors that have the same initial point. We are now going to create a parallelogram. So we know that a parallelogram has opposite sides that are parallel. So we can draw something that we think is a parallelogram, but you can see that my drawing is going to be an estimate. Now, if I want to be a little bit more accurate, I might do something like this. I might say, well, let me be very accurate. Now that is exactly parallel, right? Okay. And I'm going to erase the end there because it doesn't have to be a vector. I just want it to be parallel. There we go. And then I'm going to be now if you have your smartboard at home, you can do the same thing that I'm doing. Otherwise, you just have to use maybe an eraser, and you have to just be comfortable with kind of eyeballing it. When we move to the coordinate planes, we'll be more accurate. But there's our parallelogram. Opposite sides are parallel. Now, our sum is going to have the same exact initial point. See this initial point right here? That's the initial point of both vectors, of vector A and vector B. The sum is going to have the same exact initial point. Okay, I'm going to do this in blue. The same exact initial point as A and B, and it's going to be the diagonal of the parallelogram. And we know that this is going to be the sum as well, and look at that, it's the same exact vector. So regardless of whether or not you use the parallelogram rule, or if you find the sum using the initial to terminal side method, you're going to end up with the same exact sum. So when you're adding two vectors, you can use either rule to add the two vectors together. Now, we're going to get comfortable with what's happening graphically. So we're going to do about 5 problems. So if you printed out pre-printed notes, what you want to do is you want to, on one of your coordinate planes, you want to draw a vector u that starts at 0, 0 and ends at 6, 4. And that is vector u. Vector v starts at the origin 0, 0, and its terminal point is at -2, 5. The first sketch that we're going to make is the sketch of -u. Now, -u or the opposite of u, however you want to say that is fine. What you need to understand is that this negative here does not affect the magnitude. This affects the direction. So the direction changes by exactly 180 degrees. That means that instead of starting at 0, 0 and ending at 6, 4, our vector is going to start at 6, 4, and its terminal point will be at 0, 0. And that's what happens when you take the opposite of a vector. Or you can think of it as multiplying it by -1. Here's another sketch that we're going to make. We're going to find the sum of u plus v, and u and v are both given. Same vectors, so you don't have to draw these vectors again. You can go to the original grid that you had. Same vectors, 0, 0, 6, 4 is where u ends, and v starts at 0, 0 and ends at -2, 5. And we want to find u plus v. So I'm going to draw u. I'm going to draw v, and when I draw v, I notice that the two vectors have the same initial point. Therefore, because they have the same initial point, I'm going to use the parallelogram rule. So the parallelogram rule. I'm going to move this just a little bit up there. There we go. So if I want to create a parallelogram, I need to figure out where to put this point so that I have a perfect parallelogram. Well, one way I can think of it is this side of the parallelogram from this point right here goes left 2 up 5. So from this end point, we would go left 2 up 5. And that would be right there. I can count. So I'm thinking it's going to be right there. Now another way to think of it is maybe I don't want to use the left and right side. Maybe I want to use that bottom side. So this point would go right 6 and up 4. So this end point would go right 6 and up 4. And either way, we end up with a point at 4, 9. So now we can become much more precise in drawing our parallelogram. And the sum, remember with the parallelogram, the sum is going to have the same initial point as the two vectors that we're adding, and it's going to end up being the diagonal of the parallelogram, and that is u plus v. Okay, let's try another. Let's make sure I got both of those there. So we have u plus v, and now we're going to add u minus v, and which is actually subtraction, but I'm going to make it addition. So u minus v is the same as u plus negative v. So if I want to add u and negative v, u is going to have an initial point at 0, 0 and a terminal point at 6, 4. And the opposite of v, instead of having an initial point at 0, 0 and a terminal point at -2, 5, it's going to have an initial point at -2, 5 and a terminal point at 0, 0. And that's the opposite of v. So here we have u, and here we have the opposite of v. And if I add those two together, now we have initial to terminal, and then initial to terminal. So we're going to start at the very beginning at the initial point, and then our ending is going to be at the terminal point. And I don't know that I can use a straight edge here with this tool. Oh, but you can use a straight edge. And that right there, I'm going to make an arrowhead right there. That right there is u minus v. So depending on how your picture is set up, is going to determine on how you're going to add the two vectors together. Okay, here we're going to find 3u, or we're going to sketch a graph of 3u. Now, if I were to draw the original u, I have this vector right here. Now, in order to have 3u, the direction isn't going to be affected at all. The magnitude will. So I need to add 2 more u's to this picture to get a vector that's equal to 3u. However, to get another vector, I would have to go right 6 and up 4. So from this point, if I go right 6 and up 4, I'm going to end up off the grid. So I'm going to be off the grid just a little bit. Then I would go from this initial point and go left 6 and down 4. So you could see that I'm going to have a second U and a third U. However, I'm off the grid, and I want to show you something that's important for you to understand. When I realize that I go off the grid and I need more room on the right hand side, I can take vector u and I can just move it over. So I'm going to move it over 2 just to give myself some room. I have not changed the value of the vector. This vector is the same exact quantity as it was when it was here. It has the same exact direction and it has the same exact magnitude. Remember, location doesn't matter. So this vector is not changing no matter where I put it. It is not changing. So I just need to give myself a little bit more room. So I'm going to move it over 2 units to the left. And now I'm going to 1, 2, 3, 4, 5, 6. I'm going to go right 6 and up 4. There's a second U. And then a third U. I'm going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. And there's a third U. So my final answer is this vector in orange. And that vector is 3u. Now we're going to put the two ideas together, and you're going to try to find u plus 2v. And I'm going to challenge you to try and stay inside the grid. So see if you can stay inside the grid and not go outside the grid to sketch the graph of u plus 2v. Go ahead and press pause, and when you're ready to check your answer, come on back and I'll show you how I got my answer. Okay, welcome back. We've got u plus 2v. So the first thing I'm going to do is I'm going to draw 2v. So 2v is going to go left 2 up 5, and then it's going to go left 2 up 5 again. So this vector is 2v right here. Now, if I try to draw u and just place it where it normally is, I'm going to end up drawing a parallelogram, and I'm going to end up going off the grid. And I want to try to avoid that. So instead of using the parallelogram rule, I'm going to move this vector u. Remember, location does not matter. It's all about direction and magnitude, which is its length. I'm not changing its direction. It's still headed northeast, and I'm not changing its length. I've just moved it. And instead of using the second rule, the parallelogram rule, I'm going to use that first rule, initial to terminal, that's u, and then initial to terminal, that's 2v, and the sum will go back to the original initial point, and it will end at the terminal point. I'm trying to use the straight edge, but it's not going to let me. And it's going to end at that terminal point, which is negative 410. Now, how do we know that my u plus 2v is the same as your u plus 2v? Well, start at the initial point of your sum, go right to, and then go up 14. And if you end up in the same, at the same terminal point as I do, which would be right to and up 14 from your initial point, then we have the same exact vector. And that's how we work with vectors on a coordinate plane.